Today we're talking about lesson 7.7, which is factoring simple trinomials. A trinomial generally has the form ax squared plus bx plus c. We said that this is our quadratic, linear, and constant terms. So today we're going to be factoring when this a is 1. So it looks kind of like this. We're going to be doing a lot of different examples. So if you have a question, you can either keep watching or rewind it and listen to the previous one. So let's just quickly go over. If we have x plus 2 and x minus 7. So this is a factored form. If we distribute, then we get x times x is x squared, negative 7x plus 2x, and negative 14. Combining like terms gives me x squared minus 5x minus 14. Well, if I erase this middle line, then I can see a relationship between the two numbers here, this plus 2 and this negative 7, and that they combine in such a way to add to this and they multiply to this. So I always think of I always just say they add to this and they multiply to this. So think of like a.m., you wake up in the morning. Okay, you wake up in the a.m. Okay, so now we're going to see if we can go the other way. All right, so let's see if we can do it with x squared plus 8x plus 7. Okay, now because this is a simple trinomial, meaning there's a 1 out front, I can go ahead and set up my two parentheses and I can just say, okay, well, what times what is x squared? X times x. And now I'm going to use a little bit of number sense to say, okay, I need the numbers to add to positive 8 and they need to multiply to 7, okay? I'm getting it from like adding to this, multiplying to this, okay? Well, if they add to positive 8 and they multiply to positive 7, the factors of 7 are either 1 and 7 or negative 1 and negative 7 that would multiply to 7. So notice how they're both positive or they're both negative if they're multiplying to a positive number. Well, I'm going to take the option that matches the sign of my linear term when this is positive. Okay? So they're both positive, and the two that add up to positive 8 would be the positive 1 and the positive 7. Okay? And we can distribute this back out and double check to see if it works. All right, let's try another one. So let's say we have x squared minus 9x plus 20. Okay, now again, we're adding to negative 9 and multiplying to positive 20. So I know that my two numbers, we have x and x, this time are both going to be negative because they're multiplying to a positive, but they're adding to a negative. So I need two numbers of 20 that multiply to positive 20. So they're both negative. So negative 1 and 20, they don't add up to negative 9. Negative 2, negative 10, that adds up to negative 12. Negative 4, negative 5, that adds up to negative 9. So negative 4 and negative 5. Now I can rewrite it so that it's 5 here and 4 there. It doesn't matter. Okay. All right, so let's try some more. So now let's do x squared minus x minus 20. Okay, so now on the last two examples, we had that last sign was positive. So we knew that both of our factors had to be the same. Same sign. So x squared times x squared is x. Okay. When they're multiplying to a negative 20, I know that only one of my factors has to be negative. So I'm going to go ahead and put a positive here and a negative here. It doesn't matter the order. And then I want two numbers that when I add them together, they add to negative 1. So if I do negative 4 and 5, they add to positive 1. So if I switch that around, I do negative 5 and 4, that adds to negative 1. Okay, so notice how the negative is on the bigger sign, or the bigger number. Okay, so the negative 5 would go here, and positive 4 would go here. So my answer, this is the factored form. All right, so let's try a couple more. So we have v squared plus 3v minus 4. And let's actually set this equal to 0. So now we're going to include our zero product property, and we're going to factor and then use that to solve for v. So I need two numbers that add to 3 and multiply to negative 4. So, well, 1 and 4, if I make that negative, then that's good. So we have v minus 1 and v plus 4. They multiply to negative 4, and they add to positive 3. And now I can say, well, v minus 1 equals 0, and v plus 4 equals 0. Therefore, v equals 1, and v equals negative 4. Okay. All right, let's try an example where we're applying it. So let's say we have a rectangle, and its length is x. We'll use feet. And then x minus 14 is the width. And I'm going to go ahead and tell you that the area is 120 feet squared. So using the information I have, I know that I have the area, and I know the area is length times width. So I can write an expression where x times x minus 14 equals 120. Now, I can't use my zero product property because this doesn't equal 0. But if I distribute this out, I get x squared minus 14x. And let's go ahead and subtract 120 from both sides. And then I can have a trinomial, and it equals 0. Once we have a trinomial, we can see if it'll factor. So I'm looking for two numbers that multiply to negative 120, and they add to negative 14. So let's try maybe 3 and 40. We would need the 40 to be negative. Nope, that's not close enough. Let's try 6 and 20. That would be negative. Hey, that works. Okay, so x plus 6 and x minus 20. Now, if I use my zero product property and solve, I would get x equals negative 6 and x equals 20. So let's see which one makes sense. Now that we have an actual problem that's in context, we can see if both values work or if only one of them works, or maybe none of them will work. All right, so x equals negative 6. If I made this value a negative 6, that doesn't make sense. We can never measure a negative, so this one's out. And if I plug in 20, then that would make this 20 feet. And that would make 20 minus 14 is 6 feet. Those both make sense, and they both multiply to 120. We're good. So my answer is going to be x equals 20. All right, that's it for today. We'll do some more practice in class, and the homework is pretty short for tonight.